Good day and welcome to the April Pacific Northwest DEWS Drought and Climate Outlook webinar. My name is Britt Parker and I am with the National Integrated Drought Information System. This bi-monthly webinar series is hosted by NIDIS, the USDA Northwest Climate Hub, and the Oregon Climate Change Research Institute. It is designed to provide partners and other interested parties in the Pacific Northwest with timely drought and climate information. Each webinar will be tailored to reflect recent, current, and forecasted conditions and climatic events, but will also include discussions of observed impacts and other relevant updates from across the region. Webinars and recordings and other supporting materials will be posted on drought.gov later this week, and you will receive an email announcing the availability of the recording when that goes up. Please note that after today's webinar, you'll have an opportunity to provide feedback that will help us improve the webinar series. So please take a moment and tell us what you think. Today's speakers include Karen Bombacco with the University of Washington and Office of the Washington State Climatologist with our climate recap and current conditions, Amy Burke of NOAA's National Weather Service Northwest River Forecast Center with the seasonal conditions and climate outlook. And finally, we'll hear from Rebecca Flitcroft with the U.S. Forest Service Pacific Northwest Research Station, who's going to talk about who, what, and where, key considerations for effective freshwater protection in a changing climate. Note, we will be using the questions box at the right of your screen for questions during the presentation. You can submit those and we'll address them and additional questions during the Q&A period after the 4 presentations. Before we begin the presentations, I want to highlight the partners who make this webinar possible. The Northwest Climate Hub develops science-based, region-specific information that will assist agricultural and natural resource managers with climate-informed decision-making in Idaho, Washington, Oregon, and Alaska. You can visit their website, which will be in the chat box, to get more information. OCRI, the Oregon Climate Change Research Institute, is a network of researchers at Oregon's public universities who work with public and private entities to advance understanding of regional climate, impacts, and adaptation. It is housed at Oregon State University and hosts the Oregon Climate Service, the Office of the State Climatologist. Again, for more information, you can go to their website, which will also be in the chat box. The National Integrated Drought Information System was established in 2006 by public law with a mission to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDIS is building the foundation of a national drought early warning system through development of regional DEWS, where networks of partners and stakeholders share information and actions that help communities cope with drought. While the ultimate goal is a national early warning system, we recognize that impacts and early warning information differ across regions. Each DEWS has many of the same base ingredients, but ultimately have their own flavor to reflect the needs of their regions. The Pacific Northwest DEWS was officially launched in February of 2016, and our strategic plan and information on current activities is available on drought.gov. To facilitate our early warning system, more precipitation observations are needed. We encourage you to join CoCoRaHS, the Community Collaborative Rain, Hail, and Snow Network. This is a unique nonprofit community-based network of volunteers of all ages and backgrounds working together to measure and map precipitation, including rain, hail, and snow, as well as condition monitoring and reporting. Observation by CoCoRaHS observers of precipitation events or the lack thereof are important to capture and improve our understanding of weather. To become a volunteer or learn more, you can visit cocorahs.org or contact your state coordinator. And again, we'll put the names and emails for those coordinators in the chat box. I am very happy to welcome Jason Gerlich to the NIDIS team. Jason will be taking my place as the Pacific Northwest DEWS coordinator and will be serving this role in the Missouri River Basin Drought Early Warning System as well. I will be working with Jason over the next couple of months to ensure a smooth transition and you'll start to see Jason's name on many of the communications from NIDUS for the region. It's been my pleasure to get to know and work with all of you over the last 6.5 years, and I'm not going far, but my duties have shifted at NIDUS, and I'm happy to turn the reins over to someone who has more time to really support the region. I'm going to turn it over to Jason quickly just to introduce himself to you all.
Hey, thank you, Britt. My name is Jason, as Britt said, and I've just started here at NIDUS a few weeks ago. I look forward to the transition and to getting onboarded to work with all you folks for the Pacific Northwest DEWS. I bring a background of my previous position was at the Texas Water Resource Institute, where I worked across the state to address water quality issues and facilitated stakeholder meetings to address those water quality issues in a coordinated and appropriate way, depending on each region or county in the state of Texas that we are working in. So my background is in hydrology and agronomy, and my interest has always been in that nexus of hydrology and agronomy and water and agriculture. And here I am, and look forward to working with all you folks as the new regional drought coordinator for the Pacific Northwest. Thank you.
Great, thank you, Jason. And finally, as we move out of winter into spring, we just wanted to remind you that we really want to understand how drought, when there are drought conditions in the region, impact you. This is important for drought assessment at the state, regional, and national levels. And the National Drought Mitigation Center Condition Monitoring Observer Reports, or CMOR system, is a great way to submit the impacts you are experiencing, whether they be from too much or too little water. You can become a regular observer, and the information is accessible. The information you submit is accessible to those who assess drought in your state, and we also pull from the system for the annual Pacific Northwest Water Year Impact Assessment. So we really appreciate when you submit your impacts and they are used, and we do pay attention to them. You can go to the link on the screen, which will also be in the chat box, to watch a how-to video, learn best practices, and access social media and fact sheets. The link will be in the chat. And with that, I'm going to turn it over to our first speaker, Karen Bumbacco, to give us a bit of a recap and talk about current conditions. So give me 1 second to give her presenter control, and we'll get started.
All right. Thanks, Britt. Let's see. Are you all seeing what I'm seeing? Main slide.
Okay, we can see it now, Karen.
Okay, great. A little bit of a delay. Well, happy Monday. I hope, like myself, you spent all weekend listening to the new double album from Taylor Swift, but now it's back to the work week, so unfortunately it's on pause. Anyway, my name is Karen Bumbacco. I'm the interim state climatologist for Washington State at the moment, and I'll be talking about what's going on this water year. So going back to October 1st, on the left-hand side, we have a plot of our temperature anomalies for the water year until about last week. And really, we're seeing that throughout the whole region has been on the warm side, especially in the inland Northwest, some temperatures exceeding 2 to 3 degrees Fahrenheit above normal for the water year so far. If you look at the rankings for each individual state, they're pretty impressive. Averaged statewide, this is just October through March because April isn't over yet. We are tied as the 4th warmest in Oregon, the 4th warmest in Idaho, and the 8th warmest in Washington. So definitely a warm start to the water year. What I noticed about Washington is we're also tied for the 8th warmest, and that is tied with the 2005 water year, which many of you in Washington would remember as being a drought year. So right on track, on par with those warm temperatures we saw in 2005. But there is a difference in precipitation in that 2005 was much drier in Washington than what we've seen this year. Looking at our precipitation, there's definitely more variability throughout the region, so the statewide rankings don't tell us too much. More of a drier signal in the northern part of the Pacific Northwest, so through Washington, northern Idaho, and western Montana and a little bit on the wetter side throughout Oregon and southern Idaho so far for the water year. So looking at the last 60 days, temperatures look pretty similar to the water year as a whole. There's some near normal and cooler than normal temperatures throughout southern Oregon and southern Idaho. Precipitation, more of a dry signal in the last 60 days compared to what we saw for the water year, at least throughout Washington and Oregon. Idaho still a little bit on the wetter side for the last 60 days. But then taking that to just look at the last 30 days, we're starting to see more of a dry signal emerge, Western Washington and Western Oregon especially. Still seeing dry or warmer than normal temperatures for most of the region too, just in the last month. So what has that meant for our snowpack? This is going back to what it was in April 1st. And we can see that it was much below normal throughout Washington and northern Idaho. So that tended to be on the drier side, but if you look in the mountain sites, what really this drought is more, can be driven more by temperature than the precipitation. So in other words, what I'm trying to say is that the precipitation was below normal, but the snowpack is even lower than what the precipitation shows it should have been. And that's because we had warmer than normal temperatures, which caused some of that precipitation that we did get to fall as rain instead of snow throughout the northern tiers of the Pacific Northwest, so Montana included. Some of the southern regions fared better for snowpack by April 1st. On the bottom there, I have the statewide percentages of median. So 69% of median in Washington on April 1st, right near normal for Oregon at 104% of normal. And then Idaho is split into two regions, which pretty much aligned with how the water year played out this year, where the southern regions were very close to normal at 102% of normal. So that's south of the Salmon River, while areas north of the Salmon River and the Panhandle were slightly below normal at 74% of normal for our snow. So I wanted to show the traces just because this has been the way the water year has played out has been really interesting. So this is taking a look at our snow water equivalent going all the way back to October. So when we start building snow in our mountains to just now in late April. So this black line is the 2024 water year. And then I pulled up for Washington, I pulled up some other recent years and some recent drought years. And the bottom line here is that our snowpack is below normal in this red shading, which means it's in the lower percentiles compared to all the historical records, but not as bad as what we saw in 2005 or 2015. Those are these blue lines down at the bottom. 2015 is the lowest one. But it is aligned pretty closely with what we saw in 2001. This is the statewide average snowpack. So of course it varies by basin, but 2001 was a really dry year as opposed to this year being more of a sort of temperature driven lack of snowpack. But we're doing worse than some other areas or some other years where we had some limited drought problems like 2019. 2003 is just to compare to last year. And then 2001, we had a great snowpack, but then went into a really dry spring. I also wanted to point out this dip in snowpack that we saw in late January. This was pretty unusual to see this much snow melt in the middle of winter. And this was a really warm atmospheric river that moved into our state, well, really the whole region. And so it caused a lot of rain on snow. And then immediately following that atmospheric river, we had about a 2 to 3 day period of really balmy temperatures, really unusual warm temperatures for the middle of winter, and it caused a lot of our snow to melt off. So this overall really in Washington took us about a month to catch up to where we were if that event didn't happen. So that was really a key player this year to the detriment of our snowpack. Oregon, I just put 2001 as a comparison here, and then last year, which was much above normal snowpack. Doing much better in Oregon in the state as a whole. We are starting to melt out. Similarly, the state of Oregon was impacted by that atmospheric river event in late January. And then Idaho, also doing much better in this nice green band of median, not quite at the peak snowpack statewide due to the below normal snowpack in northern Idaho, but much better off than where Washington is, and also starting to melt out at this point. You notice a little blip here at the end of January from the atmospheric river event, but it definitely impacted Washington and Oregon more. So as a result of how poor the snowpack is, Washington just last week issued a drought declaration emergency for almost the entire state, except for these areas excluded in the Puget Sound. Washington is a little unique because it has a drought definition written in the state statute that defines drought as water supply being 75% of normal or below. And that can be either current conditions or anticipated conditions. So what really went into this declaration for Washington was, of course, the low snowpack, which is clearly below the 75% of normal threshold, but also the anticipation of having a warmer than normal spring and summer. And I'll let Amy talk about that in a bit. Another piece of the definition is whether there would be hardship. So are there going to be adverse impacts because of the dry conditions? And that's why there's been a region carved out here, which I'll get to in a minute. So focusing on Washington because they're the ones with the drought declaration. This is the Yakima Basin. This is the total reservoir storage that they have. So we're pretty close to where we were last year at this time for our reservoirs, but still below normal, which is the red line. And their most recent forecast that they put out in early April was that their senior water users would get 100% of their water supply entitlements for April through September, but they're anticipating that the junior water users in the region will only receive 63% of their entitlements just because the reservoirs are low, and also the snowpack has been below normal in that area as well. So this is why there was that carve out kind of in the Tacoma, Olympia, Seattle areas, Everett, in Western Washington. So this is a look at what's going on for Seattle Public Utilities. So the snowpack here, this is showing that in their basins where the water supply comes from, the Cedar and the Tolt, also had below normal snowpack for the water year, this red line here. But what they were able to do was, because they knew it was anticipated to be a dry and warm year, they were able to hold a little more reservoir storage throughout the water year. So the reservoirs are actually higher than average and higher than last year at this point. Right now they're not really anticipating any hardship to this system, which is why they were left out of the declaration. So this is from my colleague in Oregon, Larry O'Neill, makes this awesome plot about all the reservoirs in Oregon. Things are looking much better. I did want to point out that the Cougar Reservoir is low because there was a delayed refill for salmon. So they're keeping the flows downstream elevated relative to normal, but it's not an area of concern for Oregon because there is plenty of water in the Willamette Reservoir system. Really the only areas that are showing up with some concern are the Gerber Reservoirs and the Wickiup and Crescent Lake. And this is holdover from about 3 to 4 years of drought conditions, but still better than what these reservoirs had last year. The same can be said, I don't have a graphic for Idaho, but the reservoir storage, my colleagues tell me, is pretty good throughout the state, especially in the southern basins, the Boise Basin included, where there was above normal snowpack this year. So I just wanted to quickly show the 28-day stream flow for the region. So we're starting to see some melt out of the snowpack like those plots were showing. So normal, most of the region is in normal to above normal range where snowpack is melting. We're starting to see that kind of drier signal show up in Western Washington and Northwestern Oregon, where precipitation has been dry, especially the last 30 to 60 days. In those areas, these are all rain-dominated rivers anyway, so that's really showing the precipitation signal over the last 30 days. This is the NASA Sport LIS soil moisture percentile. So it's model data, but it is showing a dry signal throughout Western Washington and northwestern, or well, really, I guess all of coastal Oregon and northwestern Oregon as well. I'm not sure about this dry signal that's showing up in southeastern Washington and northeastern Oregon. I haven't seen that in any of the other products, so I'm keeping a close eye on it. This is the U.S. Drought Monitor as of last week. So really representing kind of the drier snowpack areas in Washington, the Cascade or east of the Cascades in Oregon, where there's been some long-term drought, and then showing those dry conditions in western Montana and the Idaho Panhandle that they've seen this water year. In terms of changes, this is pretty much aligns with where we've seen less precipitation over in the northern areas of the Pacific Northwest to where we've seen more precipitation in the southern areas of the Pacific Northwest. So some worsening of the drought categories in the northern part and some improvement in the southern. So to summarize, the 2024 water year to date has had above normal temperatures really throughout the whole region. It's been pretty consistent, but more regional variability in precipitation for the water year. Precipitation has kind of converged among a drier signal region-wide in the last 30 to 60 days. We've had bad snowpack, much below normal snowpack in Washington. We've had a drought declaration. So certainly keeping our eye on conditions, wanting to hear of impacts or projected anticipated impacts on the state level. The normal to above normal snowpack in Oregon and Idaho is good news. On top of that, at the end of the water year last year, the remnants of Tropical Storm Hillary did help the southern Idaho reservoirs a lot, even in southeastern Oregon as well. So that on top of a pretty good snowpack year, things are looking much better in those regions.
Great, thank you so much, Karen. I don't think we have any questions, just a comment on some of the Bureau of Reclamation teacup diagrams for smaller reservoirs in Southwest Oregon are showing there on the low end. So just that comment about some of the conditions in Southwest Oregon.
Thanks for that.
Great, okay. I am going to transition to Amy for our Outlook presentation. We will continue onward.
Thank you, Britt.
Hmm?
Can you hear me?
Yes, we can hear
Okay.
you and we see your slides.
Yeah, so I am Amy Burke with the Northwest River Forecast Center, and we've got a water supply email up there that you're always welcome to email questions to us. Today I'm going to talk about the water year-to-date precipitation and current snowpack, which Karen covered pretty well just now. So those are stratified geographically. We have above normal conditions in the south, and then grading up to below normal conditions in the north. We've had some recent warm spells that have begun to melt that snow off, especially in mid to lower elevations, and that snow melt seems to be continuing. Our April through September water supply forecasts mimic that gradient of above normal conditions in the south to below normal conditions in the north, especially into that Canadian portion of the domain that contributes to the Columbia. And the 3-month outlook from the Climate Prediction Center is calling for dry and warmer than normal conditions for the next 3 months. Okay, so again, covering some of what Karen already talked about, we're looking at the seasonal precipitation since October 1, which is the beginning of the water year here on the left-hand side. So we see these blue and green basins in the south, especially in southern Idaho. Upper Snake Basin has received above normal precipitation since October 1. And then focusing on these orange areas that indicate less than normal precipitation. The eastern slope of the Washington Cascades has not done great this year. And then this area in northern Idaho leaking over into western Montana has not done great. The right-hand graphic here is showing accumulated precipitation on the y-axis and time through the water year on the x. This blue line is showing this year's precipitation accumulating, catching up to this black dotted line, which is the 30-year average. We kind of caught up briefly in November, again briefly in December, and then fell behind after that. So you see this blue line running parallel to that black average line, but never making up for that early season deficit that we saw in precipitation. Looking at snowpack, much of what Karen already covered, we're seeing, I believe she showed the April 1st values, which is near peak SWE. So here we're looking at current conditions as of yesterday. So this left-hand map is showing these green basins sort of on the southern boundary of our domain, having above normal snowpack currently. But then you see that grading up into these orange colors indicating less than normal snowpack in those northern basins. The stations, this right-hand map are showing the stations themselves, again expressed as a percent normal. And again, all these numbers are the inches of water contained in these snowpacks expressed as a percent normal. So these blue dots here, or these blue rectangles, are showing stations still maintaining much above normal snowpack, but then you see that quickly grade up into these reds and oranges here in northern Idaho and western Montana, where we saw that lack of precipitation, and up into Canada as well. We have quite a few oranges. Looking at accumulated runoff, this left-hand map is showing still that same north-south gradient. This is runoff since October 1st, or the beginning of the water year. And it's really giving sort of like the long-term picture of the runoff, and mirrors some of those that soil moisture map that Karen showed. So we do see some oranges and yellows, even a red here in that little swath of dry soil in northeastern Oregon leaking into southeastern Washington, and then really across Washington through northern Idaho, we see a smattering of orange dots indicating less than normal runoff. Snapshot on the right-hand side is just today's USGS map showing percentile in runoff. So you see really this red sort of bullseye around western Washington leaking down into Oregon, where we have less than normal runoff right now in the rivers there. That's really driven by lack of precipitation in the last couple months, most of March and then April so far. We do see a lot of greens in a large portion of this area, indicating stream flows are in their interquartile range, so roughly normal. And then we see these blue dots down here in southern Idaho, where some streams are really gushing right now. We've had some flood forecasts. We've had some flooding and flood forecasts out. Karen already showed the drought monitor. I would just highlight these little pockets of extreme drought in northern Idaho and western Montana. And this does not extend into Canada, this product, but we know that there are dry conditions up there as well. So looking ahead to our 10-day precipitation, this is currently being used in our water supply forecasts for the April through September period. So the left-hand map is showing that we do have forecast precipitation in the next 10 days to fall really in a lot of regions in the area. But if you look at the right-hand map, which is showing the same information expressed as a percent of normal or percent climatology, this whole red area, which is a large portion of the area, is indicating less than normal, in some cases far less than normal precipitation for these same 10 days. The good news is, I guess I don't know if this is good news, but southern Idaho and the Upper Snake is projected to get higher than normal precipitation. That is an area that already kind of has plenty right now, maybe too much in some cases. The southern portion of the Pend Oreille here is also getting clipped by that precipitation, so that could be good news for folks there. And then I like to see these blues and greens up in Canada, where they could use some more precipitation. So that precipitation, along with 10 days of temperature forecast, are being incorporated into these water supply forecasts that I'm showing here. These forecasts are projecting the volume of flow in rivers from April through September. The right-hand map, you see the same gradient forecast, so blues to greens in the south, and then grading up to yellows and oranges, indicating below normal river conditions up there. So the table on the left-hand side is just showing some key water supply points around the region. We're really focusing here on everything above the Dalles Dam, so we're not really considering very much west of the Cascade Crest here. So this black column of numbers is showing the April through September volume forecast as a percent normal. We see most of these are below normal, with American Falls being the exception. American Falls is down here, getting everything from the Upper Snake, which has done really well this year. But if you look at this orange column of numbers, we're taking the ranking in descending order. So essentially this one here up at Mica at the very tip of Canada, or our contributing area in Canada, we are projecting the driest April through September forecasts currently. So we're projecting the driest flows there. And then these ranks in sort of the teens and below, those are quite low. So sometimes percent normal might look a little optimistic. You know, if you think, oh, 80% normal, that's high-ish. It's not. If you rank it, that would be the 13th lowest that's happened in 75 years. The Snake is doing better in terms of ranking, but still a little low there at Dworshak. And all told, this is integrating out at the Dalles to the 13th driest year. That's what we're currently projecting. And then moving on to the monthly water supply numbers, I like to look at these. First of all, I like to compare these blue bars to the green diamonds. The y-axis is showing the volume of flow for the April, for the whole water year on a monthly time scale. So you can see these blue bars have not caught up to these green diamonds, which represent the 30-year average for the majority of the months. So we've sort of been accumulating runoff deficits as the year goes on. February is the one exception here. And then you can see our projections from here on out. So for April, our projection is shown in this tiny little box and whisker plot here, and we see that we are projecting still accumulating a deficit for April. And then our box and whisker plot forecasts here for May, June, and July, you can see are significantly below these green diamonds, indicating we are projecting less than normal volume of flow coming at the Dalles for those months. And I saw the same pattern for various regions around the basin. Sometimes you can look at these and you can see if we've had a really cold spring like we did last year, you can see the timing of the melt is different. But in this case, really, we're projecting the peak to happen when it normally does in May, but for deficits to accrue during all of the major runoff months. Looking ahead at the climate predictions, long-term outlooks. So these are the 3-month outlooks. Left-hand side, this tan color over the northern portion of our region is indicating increased chances of below normal precipitation. On the right-hand side, the orange color across our whole domain is indicating increased chances of above normal temperatures. So no good news here, sorry. Basically, this is saying hot or warmer than normal and drier than normal. Looking at the ENSO or El Niño Southern Oscillation, we're looking at the Niño signal on the y-axis here, and then the various forecast periods on the X. Basically, we're seeing the trend of this product decrease and then increase again. So I think we're expecting a return of La Niña later in the season. I like to point out on the right-hand side that relationship between this, or I should say lack of relationship between historic runoff here on the y-axis and the El Niño signal on the x-axis. So this is the runoff at the Dalles for the April through September period plotted against that El Niño signal, and you see the correlation is 0.45, so it's very low correlation. It's not a very strong relationship. Our current forecast is indicated here in this box and whisker plot. It does fall along the same line as this blue trend line. So we are essentially forecasting less than normal volume flow at the Dalles during this El Niño season. Again, key takeaways are that the water year to date precipitation and current snowpack are stratified geographically with higher than normal conditions in the south. That swath of the south is pretty narrow, and then lower conditions in as you move northward. Warm spells recently have melted off snowpack. I believe we've seen our peak of snowpack behind us now, and we will proceed into the melt season from here on out. The April through September water supply forecasts, again, have that swath across the south, projecting larger than normal flows there, but getting drier as you go north. And that 3-month outlook predicts dry and warm conditions heading forward. Any questions?
Great, thank you, Amy. There is a question. Can you please define what is meant by normal? The term comes up several times, being used as baseline. Does normal refer to a specific period or average within a range of periods? If yes, what is or are the periods being referred to as normal?
That is a great question. Most of the time during my presentation, I'm talking about the 30-year average. And that's what when we refer to normal, when we compare our numbers to normal, we're talking about the 1991 to 2020 average, quote unquote normal. But there are other mathematical normals that can be used. So you can use the mean or also the median. So the mean is the average and the median is, I think of it as the middle. So you'll see different mathematical normals used for different types of data. So I think sometimes snowpack is often referred or compared to its own median rather than average. But I do believe in all of my presentation, I was referring to the 30-year average. I hope that helps clarify. And other presenters, feel free to jump in here because normals are a big topic.
Great. Anything to add to that, Karen?
Just that, yes, the same 30-year normal, 91 to 2020 was used throughout mine as well.
Great. Thank you. So I don't see any additional questions. Just a reminder, we will come back to questions at the very end. So if you do have a question for our first 2 speakers or one that comes up during our 3rd speaker, please feel free to enter those into the question box. And with that, I'm going to hand over presentation to our final speaker today, Rebecca Flitcroft, and let her take it away.
All right. I'm hoping you can see my screen at this point.
Not yet, but it's taking, there's a little delay today, so we won't panic yet.
Okay.
And while we're waiting, I'll just call out that Janelle Christensen with the USDA Climate Hub has put a couple articles and resources in the chat box if you want to dig deeper into what normals are. So you can look at those resources while we see what's going on with the presentation. Rebecca, I am going to take it back and give it to you again and just see if that corrects the issue here. Give me 1 second. And if not, I can always bring up your presentation. Okay, let's try it again.
All right. So I said share my screen. I'm bringing it up. Looking around. All right. So I'm hoping did that work this time?
It does not appear that it did. Let me go ahead and open up your presentation. And thanks for your patience. We did test all this, of course, before, but it seems like there's never a guarantee. I'm going to share my screen. And if you don't mind, you can just say next slide and we will try that method.
All right. Well, that sounds like a good way to get started. So my presentation is a bit different. So I'm talking a bit more about biodiversity and protection measures that have been instituted for biodiversity and how we might consider that within the freshwater environment. So the next slide, please. So we know that what has been done to protect freshwaters has not been adequate to support biodiversity in those environments, and that's really captured well, I think, by this Living Planet Index, which demonstrates that freshwater biodiversity is actually declining faster than in marine or terrestrial environments. Next slide. There's a diversity of threats to biodiversity, including shifting patterns of suitable habitat, human-driven land use change, climate change, invasive species, and pathogens. Next slide. And of course, all of these interact with one another, creating compounded factors that can affect freshwater biodiversity in a variety of settings. Next slide. So some folks have thought about what do we need to do to protect our global biodiversity, both freshwater and terrestrial and marine. How much of the Earth should we consider protecting? And it seems like a reasonable topic for Earth Day. E.O. Wilson offered that we need to protect half of the Earth, so 50% of the planet's land, water, and seas should be protected for biodiversity to have space to be able to adapt to the changing conditions that we see around the world. Next slide. In more recent years, global conservation groups have been targeting 30% of the world's oceans, lands, and fresh waters to be protected by 2030. And this is often called the 30 by 30 initiatives. Currently, about 15% of the land on Earth and 7% of oceans are protected, but the percentage of freshwaters that are protected is not known. And this represents a variety of different issues that come along with the designation and identification of freshwaters. Next slide. So where we identify areas for protection in freshwater, marine, or terrestrial environments is critical to achieving conservation goals. So this is an example of a disconnect that we see in a few different ways. So these are key biodiversity areas for freshwater. Those are the green dots. And those are mostly identified relating to birds, so migratory bird habitats and environments. But still, these are the key biodiversity areas that have been identified for freshwaters globally. And you can see that freshwater fish richness is on the other scale at a broader landscape scale, going from low numbers of biodiversity in the lighter color up to darker colors. So next slide, please. So you can see there's a fairly strong concentration of key biodiversity areas in Europe that are associated with migratory birds. Next slide. But some of the places around the world that have very high freshwater fish biodiversity aren't really captured in the existing key biodiversity areas that have been identified to date. Now, these key biodiversity areas are often identified based on local or national initiatives rather than looking at global patterns of biodiversity. So there's that lack of connection there between where we see biodiversity areas identified and broader scale identification of patterns of biodiversity. Next slide. We see this pattern similarly in the US. So in the US, the eastern portion of the US tends to contain more biodiversity than the western half of the United States. For terrestrial species, high biodiversity areas are also present in the Madre and Sky Islands, along those border areas between the US and Mexico. Next slide. When we consider future climate change, and we consider where we have protections in place, all of those areas that are sort of cookie cutter cutouts in the bottom maps, those are federal lands, so Forest Service and National Park System lands. And you can see that those cookie cutters are cut out more in the western half of the country than in the eastern half of the country. Further, when we look at places associated with high climate stress, those are the areas in darker blue. we can see that there's an awful lot of the areas in dark blue are associated with our federal lands. Now, our federal lands and our park system lands were not identified for conservation based on the biodiversity that was contained within their areas. Yet, very often, these federal lands are invoked as the places of refuge for climate and for concentrated efforts for conservation for biodiversity. But they may not be the best places for biodiversity conservation, even within the United States. Next slide. So when we think about the types of protections for freshwater, they fall along a spectrum of protection measures, from least solidly protected through things like best management practices to strongly protected, areas like national parks or places that have national decrees and such in place that restrict the types of activities that may occur in those landscapes. Next slide. I want to focus on a couple of the national decrees that have been identified that include freshwater. Next slide. So there are two international, globally relevant protection initiatives that include freshwater. I would point out that freshwater has been slow to the table when it comes to the identification of these areas for protection in the past. So the Strategic Plan for Biodiversity at the Convention on Biological Diversity identified in 2011 that we needed to improve the protection of protected areas in marine, terrestrial, and inland waters, and called for 17% of global rivers and landscapes to be protected. Recently, in 2021, the Kunming-Montreal Global Biodiversity Framework was the first one to actually invoke the words inland water in the protection measure, calling for 30% of terrestrial, inland water, marine, and coastal areas to be protected by 2030. Next slide. So how can the implementation of these protection measures do better in the future? In a recent publication, we identified a few ways that we envision that protection measures at a global scale can work a bit better for freshwater environments. We need to identify gaps in protection measures for freshwater. We need to accurately measure freshwaters and their protections. We need to expand existing terrestrial protected areas to specifically address aquatic biota. And we need to assess protection effectiveness. I'm going to jump into each of these topics with a little more detail. Next slide. So when I say we need to identify gaps in protections, part of the challenge here is that rivers are displayed based on spatial scale. So the number of rivers displayed at a 1 to 500,000 scale, so that's very coarse, is going to be quite different from a, say, 1 to 24,000 scale, which will start to include small tributaries and headwater areas. So when the question is, how much area of inland rivers and waters have been protected, one key question is, at what scale are we assessing those protections? If we have a lot of main stem large rivers at the 1 to 500,000 scale protected, what about all those small streams that may not be captured at that scale? They likely don't, they may not have similar protections. Next slide. We need to then really measure and actually map where freshwater protected areas are on the landscape, from headwaters all the way to the ocean. And usually there's a mosaic of protections. The protections on rivers can include buffers as well as being embedded in a protected landscape like a national park. So there's often this mosaic of protections that you might see in a river system. There are some efforts underway to do some of this mapping. Next slide. The establishment of terrestrial protected areas is more common than freshwater protected areas. And very often protected areas that are linked to terrestrial systems will have rivers or wetlands or other inland water environments embedded within them. But equally likely is that there are not specific designations or management goals associated with those freshwater environments that are located within a terrestrial protected area. So one goal is to expand the objectives of some of these existing protected areas, and where it's fortuitous to combine those terrestrial and freshwater conservation objectives by co-locating protected areas next to or within one another. This may be fairly low-hanging fruit in order to develop more established freshwater protections. Next slide. Monitoring to evaluate how well protections are working, to evaluate whether biodiversity is being conserved is a really important topic as well. And I offer up here the watershed condition framework, which is something that's been developed by the U.S. Forest Service and is being implemented at a national scale. And this allows us to understand the trends in conditions at a national scale for watersheds within U.S. Forest Service landscapes. And if you consider that the Forest Service owns and manages 17% of the land base of the continental U.S., that's a pretty significant area that could be a useful model for developing trend-based predictions or projection, an understanding of the effectiveness of protected measures at watershed scales. Next slide. So going back through those goals of how we can do better for global freshwater protections, we can identify gaps in protections. We can measure and map freshwater protected areas. You need to understand that protections aren't just a one type of protection when we consider that freshwaters need to have conservation areas from headwaters all the way to the ocean, that rather a mosaic of protections is more likely reasonable. We can co-locate existing protecting areas and expand the objectives of existing protected areas to include freshwater. And monitoring needs to be a key component in developing and understanding the effectiveness of protected areas and OECMs. Next slide. So if you're interested a little more, this is the paper where we outline a lot of these topics. So if you're interested, you can look here for a bit more detailed information than I've been able to present in this short summary. Next slide. And with that, I would like to say thank you for inviting me, and I'm happy to answer any questions if there are any.
Great, thank you, Rebecca. Let me look at questions. Let's see. There's a question about slide availability. So we do not post the slides on the website, but if you want to reach out to the speakers to ask for a copy of slides, you can. Let's see, and then we had a question about resharing the key takeaways from the last presentation. Amy, I don't know if you still have your slides up. I could quickly share screen if we wanted to go over those.
Yeah, could you share those? I don't have mine up anymore.
Okay, yeah, let me open that up, and while I do that, if you have any other questions, please put them in the chat box. Sorry, I'm paging through the presentation here. But those are the key takeaways from the last presentation for the participant who asked. Any other questions for our suite of presenters today? Okay, so with that, I'm going to also try here quickly to pull up a final slide that does have the contact information for all of our presenters. And I will remind everyone that our next webinar is June 4th. Sorry, 24th. I'm sorry, I cannot do two things at once, and I'm trying very hard to do that for you here. The next webinar will be June 24th, and we look forward to seeing you there. And let's see, here are the speaker contact information if you do want to reach out. I'm going to check the Q&A box one more time before we wrap up today. And it looks like we've covered all the questions. So thank you so much to our three presenters today. And we look forward to having you all back with us at our next webinar in June. Thank you and have a great Earth Day.